students, good morning. Now we will start haloalkanes and haloarenes, which is very important for us, and it belongs to completely second year organic. And to understand all these things, you must have some basics in organic chemistry, which we have in first year GOC. Okay, so now let's see the preparations of haloalkanes and haloarenes. So first I'll give you how to prepare haloalkanes from alcohols. Okay, so this we will discuss now. So from alcohols, if you see alcohol, generally I'll take a simple way like ROH. So this ROH, when you are treating with particular like anhydrous ZnCl2 by HCl, which we call Groves process. What this is called? Groves process it is called. Then what you will have here, RCl you are having, and along with that what you have? RCl and water, like this. Okay, so what you are having? Alcohol is converting to alkyl halide. If you are taking HCl and HBr and HI like that, then you will have a different product here. So here if you take Br here, RBr you are having. Got it what I am saying? So like that. And this is a very important thing. And here what type of alcohols are more reactive towards this Groves process? Means tertiary alcohol. Tertiary alcohol is more reactive than secondary, than primary, than methanol we call CH3OH. Okay, so towards reaction with anhydrous ZnCl2 and HCl, which alcohol is suitable? Means tertiary alcohol is more suitable, because HCl means what? Acid. What kind of acid? Bronsted acid. So it will donate H plus to this. So it will become OH2 plus. So that water will go. So that carbocation you will have. That carbocation stability everybody knows. Tertiary carbocation is more stable than secondary. Secondary is more stable than primary. Primary carbocation is more stable than that methyl carbocation. So that you know everyone. And next, if you see reaction with Mr. like what we call PCl3 like this, PCl3, then you will get RCl plus H3PO3 you will have. These are byproducts, very important. Now ROH with PCl5, with what? PCl5, again you are having RCl here, then POCl3 plus HCl. These are byproducts. Byproducts also very important. Next we have SOCl2. Okay, then what here you have? Same story, RCl plus SO2 plus HCl. Okay, so alcohol when react with anhydrous ZnCl2 and HCl, you are having RCl, and with PCl3 you are having RCl, with PCl5 RCl, with SOCl2 you are having RCl, like this. Got it what I am saying? So these are very important for us. Getting sir? And one more important, and suppose if you are having bromine in presence of NH2OH like that, then also you will get RBr. And if you are using chlorine, then RCl you are having. Then RBr plus remaining like NH3 plus H2O. NH3 plus H2O you will have. This is one of the preparation to get what? Alkyl halide actually. Got it? So next few more we will discuss. These are from alcohols. Alcohol when react with anhydrous ZnCl2 plus HCl. This is a Groves process. What is a Groves reagent? Anhydrous ZnCl2 plus HCl. Okay. So here I can tell you one thing, that ZnCl2 act as Levy's acid. Okay. It will accept Cl minus, so that it will provide H plus, like this. So you are having HCl. So now ZnCl2 you are having, and these both will react. Now it will be ZnCl3 minus, okay, plus H plus, like this. This H plus will add on this alcohol. So you will get ROH2 plus. So water will go. So that again from here Cl minus will add on carbon. So this is very important for us. Hope you understood this one. Okay. So next we have to discuss some other preparation of haloalkane. This actually in first year we know from alkanes and from alkenes and like from alkynes. Okay. So addition of halogen or addition of HX to alkenes and alkynes, you have one way, and one more, this particular substitution, free radical mechanism of substitution of halogen on alkane you have. So from alkane you have, from alkene you have, from alkyne you have. Okay, alkanes with the halogen directly, you will have haloalkane by free radical mechanism. This is very important. So next is same from you can say alkanes now. So preparations of same haloalkanes from what? Alkanes. So simply we call this as halozination. What is this? Halozination. What is halozination? Substitution of halogen on alkane. Okay. So if you see it's like some ethane like this, CH3 single bond CH3, when react with fluorine, it can react even in dark actually. So if I use a fluorine, I can use simply dark, that's it. Then what happens? This is the explosive reaction. Then you will get CH3CH2F plus HF. It's a highly explosive reaction because F single bond F dissociation energy is very less. As of you know, the fluorine is highest electronegative atom. This is a very important thing. Next, come to another particular reaction. CH3 single bond CH3 means ethane. When react with the chlorine, sunlight is required. So here light not required, here light required. So towards halogenation, who is more reactive means fluorine, then chlorine, then bromine, then iodine, like this. Now what you have here, simple CH3, CH2, Cl plus HCl. This is what? A free radical mechanism. Free radical mechanism. This happens by 3 steps: chain initiation, chain propagation, and chain termination. Okay, in hydrocarbons also you will have as a property of alkane. Okay, so there you will have more elaborately by using 3 steps. One is chain initiation, chain propagation, and chain termination. And with bromine, if you see next reaction, ethane, when react with like bromine, then here what requires? Some heating is required. Some heating is required. It's less reactive. Here what you are having is CH3, CH2, Br you are having. And if you use iodine instead of remaining halogens like CH3 single bond CH3, I2, if you are using, some catalyst also required. Heating is required. Okay. So here some catalyst like iodic acid like HiO3. Okay. And some kind of another reagents like metallic reagents we can use here. Then you will have CH3 and CH2I. This is iodoethane. What we call iodoethane. So these are from alkanes actually. So from alkenes also we have. And before that, if you have 2 different kind of carbons, here both carbons are same kind. If you are having carbons like this, and I am using some X2 here. Okay, why X2? And simply I use chlorine here. So in presence of sunlight, you will have 2 different products here. What are the 2 products here? So substitution can be here and can be here. Correct? So chlorine can substitute here, means H dot can be removed from here or can be removed from here. So as of secondary is more stable. Secondary free radical is more stable than primary free radical. Actually, tertiary free radical is more stable, but here tertiary is not there. That's why I am talking about the secondary. This is the secondary and this is primary. Everybody knows. So chlorine will substitute here one case and chlorine will substitute here second case. But here major product. That means what you have product here? CH3, CH, Cl, CH3, and one more is CH3, CH2 and CH2, Cl. This is another product. So this is a secondary and this is primary. And this one is a major and this one is minor product. Hope you understood. So this is about what we call preparation of Mr. Haloalkanes from alkanes. Next, we will see from alkenes. Okay. So here also the most important thing, we are substituting halogen based on stability of free radicals mainly. So tertiary carbon is more stable than secondary. Secondary is more stable than primary. Okay. So if tertiary carbon is there, so at tertiary the substitution will be easy. Got it? So here we can have a few more like that examples, like CH2 double bond CH and CH2 when react with the chlorine, what happens? See, C6H5 and CH2Cl, CH2 CH3 here we have, and toluene when react with the chlorine. Okay, this is CH3 actually, sorry, CH3. Now I am having like the CH3 and CH2 and suppose CH3 I am having, and this is reaction with the chlorine. So this is number 1 and this is number 2 and this is number 3. So my question, who react fast among these? Means this react fast with chlorine. Who is more reactive? Means second, then first, then last is 3. Means propane is less reactive with chlorine when compared with this toluene and this. Do you know what is the reason? Chlorine, when it is going to substitute on this methyl, suddenly what happened here? C6H5, CH2 dot will come first, means benzyl. It is benzyl free radical which is stabilized by resonance. This is stabilized by resonance. Afterwards Cl2 is there, no? By homolytic cleavage this will break equally. So Cl dot will add on this, so that you are having CH3CH2Cl. So due to formation of stable benzyl free radical, this can react fast. Okay, same here, allyl free radical you will have. Allyl. Allyl means like CH2 double bond CH and CH2 dot will come first. And for that, this chlorine dot will substitute here, so that here what you are having, CH2 double bond CH and CH2Cl you are having. This is allyl chloride. When we call allyl, this sp2 carbon attached to sp3 carbon. So this is sp2 and this is sp3 carbon. So for any sp3 carbon which is attached to sp2 carbon, for that sp3 if any functional group or substituent added, then that is called allyl. Benzene attached carbon, if any group you have, that is called benzyl. What this is called? Benzyl. This is what, as I said, allyl. Got it, sir, everyone? This is allyl and this is what? benzyl. Got it, everyone? So this is about one more important relation, means which can react fast, means that depends on stability of free radical. Remember, in free radical stabilities, benzyl is more stable than allyl than tertiary actually. If you see one more actually like this, CH3, C, CH3 and CH3 and H if you are having, if I am adding chlorine now in presence of sunlight. Now what is the order of reactivity? First this, next tertiary, next this. In that way you will have. Okay, so this is the most important thing you have to remember. Got it, sir, everyone? So this will be more reactive even than this three. Third one. Okay, this is fourth if you take. Got it? So please you have to apply like this. Okay, so this substitution is depending on what? Means exactly stability of free radical. Got it, sir? You can check the stability of free radicals and all in first year general organic chemistry. So in GOC again we will discuss, no problem. Okay, so from alkenes now. From alkenes, when you are taking some alkene like this, no problem actually, CH2 double bond CH2, when I am adding Mr. X2, like instead of X2, I'll take some Br2 like this. Then what happens here? CH2 single bond CH2 you are having, and here one bromine and here one bromine. Correct? This is called vicinal. What this is called? Vicinal dihalide. Okay? So definitely bromine will substitute by breaking of this double bond actually. Okay? By formation of intermediate like this, bromine Br plus, so that this will come over here. One more Br minus will add on this, so that you will have this vicinal. Okay, in this way you cannot have geminal. Geminal means two halogens to the same carbon. Is it possible? No, not possible here, because one is Br plus and one is Br minus in Br2. So Br single bond Br. So first it will be like, if it is coming over here, suppose. Okay, so first this carbon gets positive charge, right? So that this lone pair will add on this. So this carbon have what? Positive charge. Like that you have to check. So this will go as a Br minus. So that Br minus is adding later on. So this is addition. Okay, but if you have different carbons like this is symmetrical alkene, because both carbons you have same number of hydrogens. So here if you see, this carbon is different, this double bonded carbon is different, and this double bonded carbon is different. Now if I am going to add Mr. Br2, if I am adding Br2, no problem. Here one bromine you will have, here one bromine you will have. Okay, but first where it will add means first here, because here positive charge is more stable, right? So first this Br will add over here, so that positive charge, so this will come over here first. So this gets positive, so here it gets negative. So that first Br lone pair will come over here. Understanding what I am saying? This gets positive. Why here only? Because this carbon is more stable with positive charge. Because secondary carbocation is more stable or not? That's what I am telling you. So that Br will come. So why I am telling like this? First where bromine will add means here. That we have to remember. And of course the product is same. What is the product here? You are having a CH3 and CH and Br here and CH2 Br here. Of course you can take bromine instead, you can take chlorine, you can take iodine also, not a problem. Okay, so one more important thing is you have to write what I am saying. Okay, so this is a recorded video. Definitely you can pause the video. Oh, he is erasing. Don't think like that. You can forward or you can go back and you can pause and you can write all these things. Okay, so not an issue. This is from alkenes. And if you see next from alkynes, from what, sir? Alkynes. Alkynes when react with Mr. what we call with a bromine or iodine or chlorine, you will have the same manner, but 2 moles is required because alkynes means you have triple bond, right? So if you see like this, CH, triple bond CH I'm taking first, symmetrical. Then if I am adding first bromine, so first what happened? Then CH, double bond CH, here one bromine and here one bromine. And one more they can ask question, I forgot to tell you, this bromination is anti-addition. Anti-addition. This halozination to any particular alkene or alkyne, this is anti-addition. Why anti-addition? This bromine, first bromine is coming from below the plane suppose, then Br minus will come from above the plane. So this is the most important thing. Okay, you have to remember. So CH triple bond CH, for this when you are adding bromine, then you will get CHBr double bond CHBr. Got it? So this is the most important thing. So I will give you commonly one important thing. If we take cis and trans compounds, if particular reagent added by Sn addition, then what you will have? In optical isomerism you will have that, don't worry. Okay, even I was not given, please remind me. I was given previously for our previous students, but if any new students, those also can learn. Okay, I repeat, for cis and trans, how anti-addition products will come and how Sn addition products will come, means with some racemic mixture how coming and only meso how coming. Okay, like that I will tell you. Okay, sir. So those are very, very important. Now just I'll give you just brief reactions, how addition happening. This is anti-addition. Anti means both Br plus and Br minus. One is electrophile and one is nucleophile. How they are adding to alkene or alkyne I am giving you just now. Okay. Now again if you add a bromine, what happens? Now tetrabromo you will have it. So one bromine here and single bond now CHBr. So this is anti-addition, that's why I am writing like this. Got it clearly? So this bromine and this bromine previously added, and this bromine and this bromine now second time added, opposite way. So these are important what we call preparations from alkenes and alkynes. So this is just halozination again. Halozination. I was not given that addition of HX. Okay, addition that will be called hydrohalozination. We call addition of HX like HCl, HBr, HI, those. Okay, for that we have to follow, means addition of HX for particular alkene we have to follow what? Markovnikov rule, that you know already. So that we have to follow. So addition of HBr suppose to alkene, because for HBr only we have this kind of exceptional things. Okay, here we use Markovnikov rule and Anti-Markovnikov rule. What is Markovnikov rule? Addition of negative species to the double bonded carbon should be done for what? Double bonded carbon which have less number of hydrogens. That is very, very important. So I repeat, according to Markovnikov rule, negative species should add to the double bonded carbon which have less number of hydrogens or no hydrogen. That is called Markovnikov rule actually. So this Markovnikov rule we will follow for HCl, HBr, HI. One more is there, Anti-Markovnikov rule. That Anti-Markovnikov rule is what means? According to Anti-Markovnikov rule, in presence of peroxide, negative species will add to the double bonded carbon which have more number of hydrogens. This is most and most important thing. But this anti-Markovnikov reaction, when we have to follow, means in presence of some peroxide like H2O2 or else some benzoyl peroxide. Even they given peroxide on arrow, but the added substance is HCl or HI, no anti-Markovnikov rule. Anti-Markovnikov rule only for addition of HBr and water. This is the most important thing. Please note it down. What I am saying, understanding? So I said two things according to Markovnikov rule and according to anti-Markovnikov rule. Okay? So I repeat, negative species must add to the double bonded carbon which have less number of hydrogens. That is Markovnikov rule. In presence of peroxide, that negative species will add to the double bonded carbon which have more number of hydrogens. That is anti-Markovnikov rule. Anti-Markovnikov rule we use two times. One is addition of HBr and addition of water. This is the most important thing. Suppose you are adding this CH2 double bond CH2. When I am adding HBr, no problem. I can add bromine either to this carbon or this carbon because it is a symmetrical alkene we call. This is what? Symmetrical alkene. You can add to anywhere. You can add here or you can add here. It's no problem. Understanding everyone? So this is H plus and Br minus. So this will migrate over here. Suppose this carbon gets negative charge and this carbon gets positive charge, right? Then even if I am taking like this, I am taking like this. If this double bond migrated, means pi bond migrated over here, this gets minus and this gets plus. Both are same. CH2 minus, CH2 plus. In previous also, CH2 plus and CH2 minus. Both are same. Now H plus will add to the negative carbon and Br minus will add to this carbon. Negative species will add to what carbon I said? Double bonded carbon which have less number of hydrogens according to Markovnikov rule. But if I write here in this reaction, definitely you will laugh. You don't know organic chemistry, that's why he is writing. Because here Markovnikov rule not required. Because both carbons are same. But generally, when there is no peroxide on arrow, so that's Markovnikov rule. To say that, I written here. So now the product is CH3 and CH2. Here Br you are having. Here Br you are having. So here you are having CH2 and H. So HBr was added here. Correct clearly? So this is addition of HBr to a symmetrical alkene. Suppose if I am taking unsymmetrical CH3, CH, double bond CH2, I am adding HBr in presence of nothing. Nothing is there on arrow, means what we are following here, this is according to Markovnikov rule. That means what you have to see, that negative species means this Br minus should add to the double bond. Two types of double bonded carbons you have. This is one kind of double bonded carbon, this is another kind of double bonded carbon. So both are carbons only, no sir, but hydrogens are not same. This carbon attached to two carbons and have one hydrogen. This double bonded carbon attached to one carbon but having two hydrogens. So this carbon is a secondary carbon and this carbon is like a primary actually. Of course we won't say for double bond, just for your understanding I am saying. If this bond migrating over here, then you are getting secondary carbocation. Correct or not? If the migration happen in this way with the black marker I am using, here you are having plus. So primary carbocation you are having. Which is more stable means secondary is more stable. So that this negative species, this Br minus, will pakka add to the second carbon, the secondary carbon, because secondary carbocation is more stable. That means what is the product here? You are having CH3, CH and CH2. So Br come here, will come here, and hydrogen will come over here. Okay, and one more. This is actually major. One more in this black color. This is the number 1 possibility, and this is number 2 possibility. Suppose. So this is the number 1 possibility product, and the second product is if this is migrating over here, this carbon gets positive charge. So Br minus will come over here, so that CH3, CH, and CH2, and here you have a bromine, and here you have a hydrogen. So this is major product and this is minor product. What is the reason? This is a secondary halide and this is primary halide. This is the second product. Sir, don't think, sir, here secondary written, here 1 written, don't think. In a first migration, meaning the first migration is correct, because in first migration this middle carbon you are having secondary. In a second migration, this carbon, primary carbocation you are having. Which carbocation is more stable? You know that. Tertiary carbocation is more stable than secondary. Secondary is more stable than primary. This you know already. So this is about Markovnikov rule. Okay? And in Markovnikov rule you have one more important thing. Please write it down, all these things. Okay? What is that? If double bonded carbon, listen carefully, if double bonded carbon, adjacent carbon if more stable, okay, then migration takes place, either methyl group migration or hydride H minus migration takes place. That we call 1,2 hydride shift or 1,2 methyl shift. I will write those reactions. If you see CH3, CH, okay, and here CH3, and here CH, double bond, CH2. When I am adding Mr. HBr, what happens? So this, of course, many times I told. So actually this one is a secondary, as I said, right? So this one is primary. Like that you have tried before only. Okay? Imagine just here, as double bond is going to remove, of course will remove after addition. So this one is a tertiary. Why tertiary? For this, how many carbons attached? 1, 2 and 3. So this is tertiary. So double bonded adjacent carbon, if you get more stable carbon, then this particular hydrogen will migrate over here. Okay, then this Br minus will add on this particular. Get it? Actually, according to Markovnikov rule is what we have to consider. The negative species will add to the double bonded carbon which have less number of hydrogens. So this Br minus we have to add over here. Actually, according to Markovnikov rule. So first here carbocation will come pakka, secondary carbocation. But if this hydrogen migrate over here, so this Br minus will come over here. Correct? So that it will become tertiary or not? Understanding? This hydrogen as H minus if it is going, so this carbon gets positive. So this carbon is what carbon? Tertiary carbon. Tertiary carbon if positive charge, that is called tertiary carbocation. So this hydride will migrate over there. So what you are having now, the product, this particular CH3 and C, and here you have a methyl, and here CH and single bond CH2. What I am writing, just see. So first this will migrate like this, so that secondary carbocation you are having, first secondary carbocation you are having pakka, and this hydrogen will add on this particular carbon. So this will become CH3 first. Okay, why I am showing? This particular hydrogen was added. This particular hydrogen, star I will keep. Okay, actually now here you get positive charge. I will arise, simply listen carefully. So actually Br minus must come over here, but this hydrogen along with this bond will migrate over here. so that this hydrogen when migrate over here positive charge will come. Getting what I am saying? So first positive charge came over here. That positive charge nullified by this H minus, cancelling charge, because H minus migrated over there. So this hydrogen if move there, what happens now? So if you see simply now, let's see. Now this hydrogen from here, okay, migrated over here, that hydrogen. Okay, so I'll write with the black color. Migrated hydrogen from here, this black color hydrogen. So that as H minus if that gone, so here you have a positive charge. Which positive charge? Tertiary. Because this carbon have 3 carbons surrounded to him. So this positive charge will be cancelled and now Br minus will come over here. Understood? So first hydrogen added over here, from this, and here secondary carbocation you have, and this H as H minus shifted over here, so that tertiary carbocation you have, so Br minus added over there. So this one you called as a tertiary, so now it's a major product, and this was formed due to 1,2 hydride shift. What shift? 1,2 hydride shift, this one. Okay, you can have 1,2 methyl shift like the same manner. You are having this CH, double bond CH. First you have to observe what we have over there. So first you have to write, okay, just in you have to say that okay, this is primary and this is secondary and this carbon is tertiary. This one is tertiary or not? Okay, this one is tertiary. Okay, so first H will add over here, migration should be like this, no problem. Okay, always positive charge is more stable in secondary than primary, that's pakka. So bond have to migrate that side. Okay, so first this hydrogen will come over here, this hydrogen, so that here positive charge, but this secondary, but here positive charge. If this methyl is not there, then 1, 2, 3, so this will be tertiary. So this methyl can shift over here, so that tertiary carbocation is possible there. So here what shifting happen? 1,2 methyl shift. What shift that is called? 1,2 methyl shift now. So what happens? What I am saying, understanding? So listen carefully. This particular bond is migrating. This particular methyl will come over here. So I will keep a star here. That methyl, first hydrogen, this hydrogen will come over here. First you write down skeleton structure. Like this CH3, C, one of the methyl will be same, and C, H, and single bond CH2. One hydrogen came from this. I will keep a star here. Okay, but I will write here black. Now this methyl group, what is shifting here? I will use a blue. And which methyl shifted? This methyl shifted. So I will keep a star over here. So when this methyl shifted over here, this carbon will become tertiary now with a positive charge. That positive charge will be cancelled by this Br minus. So now remove this positive charge, and here you have Br like this. So CH3, C, CH3, Br, and CH, CH3, and CH3. So what happened? See now, this H will be here, this Br will be here. This methyl, if you want, I will write a blue color, not a problem. This methyl which is the shifting, I written as a blue color. So this methyl shifted over there. So why not this methyl? Don't ask me. Both are methyl groups. Any one of the methyl group will shift. So this what we call 1,2 methyl shift and 1,2 hydride shift. In this kind also you will have those methyl shift and hydride shift like this. Okay. So here you have, and here you have a double bond. Now I am adding Mr. HBr. So here you can see. So actually this is what we call secondary, and now this is tertiary. How I am saying tertiary? This carbon, if you see, 1, 2, 3, 3 carbons attached. So double bonded carbon adjacent is more stable. So from here, hydrogen will migrate over here. So this Br will come over here. So what will be the product? So you can write that product particularly now. So here you have methyl already, and the bromine will come. So first this hydrogen will add here. This particular hydrogen. I will keep a star here. Okay, first hydrogen here, positive charge here, hydrogen as H plus here, migrating like this. So H plus will come over here. So here positive charge, but positive charge than here is more stable. So this hydride will shift as H minus, so that positive charge will come. So this tertiary positive charge will be nullified by Br minus, cancelled by Br minus. Got it clearly? So this is about 1,2 hydride shift and 1,2 methyl shift. Got it, sir, everyone? So this what we call preparations. Okay. So in preparations, again from alkenes, if you see, Anti-Markovnikov rule is there. And CH3 and CH double bond CH2, when I am adding HBr in presence of benzoyl peroxide C6H5CO whole twice O2, benzoyl peroxide, or else you can use hydrogen peroxide H2O2, H2O2. Okay, simply some people on arrow they give peroxide. On arrow, if you have either benzoyl peroxide or hydrogen peroxide, now this rule what we call Anti-Markovnikov rule. Now this Br minus, this is negative species, will add to the double bonded carbon which have more number of hydrogens. Here no migrations. So here what you have, the product particularly CH3 and CH single bond CH2 here. So H will be here, Br will be here. What is the difference between previous one and now understood? So HBr, if there is no peroxide, Br here, H here. When that particular shifting happens, means if the double bonded adjacent is more stable, then only shifting happens. Okay, just have all these things. These are all very important. Please have a look and remember everything. Okay, and even if you are using like this CH3 CH double bond CH2, I am adding HCl. Even I use peroxide, no effect. Peroxide effect, as I said in previous before itself, is only for HBr and Mr. Water. Okay, so now there is no Anti-Markovnikov rule here. Means the product won't be like this. Here the product will be the same manner. Migration over here. So Cl minus will be here and H here. So the product will be according to Markovnikov rule only, even use peroxide. So the product here is Mr. CH3 and CH and single bond CH2. So here you have a chlorine and here you have HCl. Got it? So this is the way of understanding both particular Markovnik and Anti-Markovnikov rule. Okay, so this is the very, very important reaction for us. Okay, so even if you use particularly from alkynes, if you use alkynes, what happens? Okay, so next is addition of HX to Mr. HX2 alkyne. 2 times we have to add. How many times? 2 times. If I am taking this CH, suppose triple bond CH, For this, if I am adding Mr. HBr, then so sir, Markovnikov anti-Mark not required because both are symmetrical carbons. So now you are having CH2 double bond CHBr. Now for this, if I am adding again HBr, again I am adding HBr, sir. Okay. For this, again I am adding HBr. I have a peroxide in one way, in this way I don't have any peroxide here. So what is the product? So here the product is, if I use peroxide, then the particular negative species means Br minus will add to the double bonded carbon which have more number of hydrogens. So here our product is CH2 and Br and single bond CH2Br. Means H was added here as H plus and Br here. Okay, very simple reason why this Br minus is adding over here. So here it is more stable here, positive charge. So Br minus or Br dot will come over here. But if you add this HBr like this, if there is no peroxide, then the product is CH3 single bond CH Br and Br. This is what? According to Markovnikov rule, and this is according to Anti-Markovnikov rule. Understand? So here what happened? Here Br minus will come over here, and here will have H. So here according to Mark, this is gem dihalide and this is vicinal dihalide. Most important thing. Understanding, sir? So very, very important for us. Okay, and the most important thing, please remember. Okay, even you can use this triple bond CH. When I am adding HBr, so first Markovnikov rule. Correct or not? What is that? This negative species will add to the double bonded, unsaturated carbon which have less number of hydrogen or no hydrogen. So no hydrogen also you have to consider. So here no hydrogen, here one hydrogen. So this negative species will come over here. So what is the product? You can write CH3 and C double bond CH. Okay. So here you have bromine and here you have hydrogen first. Same. If I am using HBr and there is no peroxide, then Br here, H here. According to Markovnikov rule, negative species will add to the double bonded carbon or unsaturated carbon which have less number of hydrogen. So here no peroxide. So according to Markovnikov rule, what rule? Markovnikov rule. So that here the product is and CH3 and C and one Br here, another Br here, and a single bond CH3. So gem, you have to understand, if the addition happening by Markovnikov rule for alkene, then the product is gem dihalide. One time Markovnik, another is anti-Markovnik, like that. You will have vicinal. Vicinal means two halogens at adjacent carbon. So these are very, very important preparations. Next, few more we have to discuss. Like we have some alkyl halide, another alkyl halide, this replacement. Okay, like we called replacement of halogen. Simply we call that reaction Finkel stain reaction. So this is substitution of halogen by other halogen. So remember, for this the order of reactivity, iodine is a better reactive, means replacer. Okay, means bromine, next chlorine, next fluorine. That means iodine can replace all these three from alkyl halide. bromine can replace chlorine and fluorine from alkyl halide, and chlorine can replace only fluorine. I repeat, from alkyl halide. Iodine can replace any one of these. Means if you took alkyl bromide, alkyl chloride, alkyl fluoride, this iodine can replace, because I minus is the best nucleophilic order. So you can see I minus is greater than, Br minus is greater than, Cl minus is greater than F minus. Got it? So here this in Finkel reaction, suppose CH3 CH2, suppose if I am taking chlorine, if I am using Mr. NaI in presence of acetone, then what you are having, CH3 CH2I plus Mr. NaCl. That's it. This is a Finkel reaction. See, I minus is replacing chlorine or not? But if you take reverse reaction like this, CH3 CH2I when react with Mr. NaCl in presence of acetone, then you can say this reaction won't happen. Understanding, sir? So very important, please remember everybody. So this reaction won't happen. When this reaction happens, so higher halogen can replace lower halogen. Lower halogen cannot replace higher halogen. This is the most important thing. If suppose here chlorine and here bromine, yes, the reaction happen. But here bromine and if here chlorine, no reaction. Got it? So this is about a Finkel reaction. Next, Henderson reaction. Henderson's reaction. Silver salts of carboxylic acid when react with the bromine like this. CH3 COOH, silver salt of carboxylic acid when react with the bromine, then you will get CH3 Br plus CO2 plus AgBr. Like this you will have with one carbon less. Silver ethanoate or silver acetate, you will get methyl. Propanoate, ethyl halide. Okay, so this is one of the important reaction. Okay, so if you use fluorine here, you cannot, but the fluorine can be replaced by chlorine like this. Correct? So these are the important preparations of haloalkanes. Okay, so next we have what properties of haloalkanes, haloideans. Okay, so we have to discuss next what properties of chemical properties of haloalkanes, properties of haloalkanes. First we have to discuss. For this you have to understand two important things. One is Sn2 mechanism and Sn1 mechanism. Sn2 mechanism means, what is this? Substitution bimolecular nucleophilic reaction. Okay, yes, you have here Sn by here too, or substitution nucleophilic bimolecular reaction, both are same. Okay, so Sn2, bi means 2, no? Why? In this kind of mechanism you have to consider alkyl halide which have less number of branches, means small groups you should have, like hydrogen, and here also like hydrogen or some methyl group is there. If a branching is less, see, this is what we call primary halide. In this mechanism, nucleophile means, you know, that Nu minus, that approach from a backside. So halogen will remove. Halogen will be removed. Simultaneously happen. Nucleophile will approach from a backside and halogen will remove from front side. Okay, when it happens, when these groups are very small, so that between the groups you will have less repulsions. Steric hindrance we call. If the groups are big, between them repulsions more takes place. Those repulsions we call as steric repulsions or steric hindrance. When the steric hindrance happen, when the groups are very big. So when Sn2 happen or when Sn1 happen, you can say based on the groups attached to this particular carbon. Which carbon you have to consider? The carbon for whom halogen attached. This particular carbon we call as a substrate carbon. What carbon that is? Substrate carbon. For substrate carbon, nucleophile is approaching from a backside. This nucleophile will ask this carbon, hey carbon, substrate carbon, I will come and I want to form a bond with you. Who will ask this nucleophile? Then this substrate carbon will say, Mr. Halogen, I wanted to form a new bond with Mr. Nucleophile. He is more reactive, so I cannot help you. So you please leave because he is more reactive than you. Who is saying? This carbon. To whom? This X. Suddenly this X feel okay. Poor X, because then X more powerful negative species is coming. Then this X feel some fear. With fear, this will say, okay, I will leave. Who will say? This X. This nucleophile is approaching from backside. Understanding what I am saying? Just conversation, just for our understanding. Okay. Now what happened? This C you are having. So actually one should be above the plane and one should be on the plane and one should be below the plane, like that we have to mention like this. And here you have, this is above the plane. Certainly you have more space and these two are within the plane. So here you have within the plane this methyl and this X will be removed simultaneously, delta minus. This another like nucleophile will Nu minus is approaching, and here you have hydrogen and this methyl, hydrogen you have over here, one more hydrogen like this. Got it? So this particular state is a very much unstable. Do you know why this is unstable? This particular substrate carbon, if you count, consists of 5 groups. 1, 2, 3, 4, 5. So this is a called transition state, which is very much unstable. Then this carbon will force this, Mr. Halogen, please go. That will push. Suddenly, the particular compound will become like this. This all groups will force this X, please go, please go. Suddenly, what happened? This particular above the plane hydrogen will go this side, hydrogen, and now this will be here like this, and this will be methyl. Okay, so methyl is going there, all going like this, and this nucleophile is coming like this. You can represent like this, or else you can represent like this. Here you have a methyl, and here you have a below the plane hydrogen. So this particular Nu, this is not UN, Nu, you can write like this also, Nu, nucleophile. Very clearly? Now this particular is called inversion of configuration. This is also called Walden inversion. What inversion we call? Walden inversion. So this nucleophile is what exactly? Means you can take like OH minus, Cn minus, NO2 minus, ONO minus, NC minus, isocyanide. Okay, isocyanide, NC minus, like this you can take. What is a nucleophile? Okay, so who is leaving? This X is called leaving group. This inversion, what we call Walden inversion. Hope you understood. Okay, these nucleophiles will attack like SH minus. Okay, these all are the nucleophiles which will replace X from this substrate carbon. Like so many other like RCO minus. Correct? So even RONA means RO minus Na plus. This RO minus alkoxy. These all are nucleophiles which can replace this X by this mechanism. When this mechanism happened, when the groups are very small. Why this is called bimolecular? Because here rate of reaction means R. This depends on both this substrate alkyl halide concentration as well as this nucleophile concentration, because this nucleophile should be very much reactive, should be very strong to replace this X. If it is poor, if it won't have such energy, it cannot replace X. So this concentration of nucleophile also very important. So here you have to take powers 1 plus 1. So what is the order of reaction here? Order is 1 plus 1 2. Okay. So in this way, this nucleophiles order I was given, and rate of reaction is 2. That's why it is called bimolecular. Molecularity is 2, order is 2. Bimolecular reaction. This is Sn2 mechanism. When Sn1 mechanism happen, means when the groups are very big, then incoming nucleophile cannot approach from the backside, because backside you have very big groups. Certainly between the groups you have more repulsions, so nucleophile cannot approach from backside. Then what happen? First leaving group will go and forms carbocation, then that nucleophile will add. That is Sn1 mechanism. Why this is Sn2 understood? Okay, this is the most important thing for us. Correct, sir? Here if you see, what alkyl halide can undergo this kind of mechanism easily means Ri can easily undergo order of reactivity, means which can react fast. Ri, then Rbr, then RCl, then Rf. So Ri, because I minus is the best leaving group. Which is best leaving group? Order of leaving group. I minus is greater than, Br minus is greater than, Cl minus is greater than, F minus. So this is best leaving group. Who is the best leaving group? I minus. Hope you understood all these things. Okay. So Sn2 mechanism I was given, and Sn1 mechanism, if you see, very simple. These groups should be very big, then first X will go, then carbocation you will have. See, in previous also I was given clearly what is the order of Sn2 mechanism. Okay, which alkyl halide can react fast. That also I was given previously. So towards Sn2, which alkyl halide can react fast? Means if you see, Sn2 means nucleophile should approach from backside, so group should be very small. That means methyl halide, any methyl halide. Okay, among iodide, bromide, chloride, who is more reactive? Iodide I said. Now halogen is same. For a same halogen, which alkyl halide means primary or secondary or tertiary, which is more reactive? I am telling you now. So methyl halide is more reactive towards Sn2, order of reactivity. This X you just take like fluorine here. Suppose here also fluorine. Then here chlorine, here also chlorine, like that. CH3, CH2X. This is super primary we call it. Super primary methyl halide. This is primary. Next is what? Secondary. Secondary means CH3, C, and here X you have, and CH3. This is what? Secondary halide. For same halide I am comparing. Remember, if it is bromine, this is bromine, this is also bromine. Among all kind of same bromides, which kind of alkyl bromide is more reactive means methyl bromide is more reactive towards Sn2, means through formation of transition state nucleophile approach from back side so that X will go from front side. This is the most important thing. Then you have tertiary like this, CH3C and CH3 and CH3X. Actually benzyl allyl are there, we have no need to consider because tertiary even cannot undergo by Sn2 mechanism. See, the reason groups are very big, so the nucleophile cannot approach from backside. Nucleophile approach from backside is not possible. So this is a most important thing. If you see Sn1 mechanism, it's not like that. Nucleophile won't approach from front side. Sorry, please. Nucleophile won't approach from backside because groups are very big. Now we have to consider Sn1 mechanism. If you consider Sn1 mechanism, you have to consider somewhat. Here you have a methyl. Okay, this is above the plane, and here you have below the plane. Suppose one more methyl is there, and here you have one more methyl, and here you have X. Now the nucleophile is wanted to come over here. No, it can't. Why, sir? You have this much of space. Nucleophile this much, it can come over. See, on paper you have a more space, but practically this carbon has 3 hydrogens, this carbon has 3 hydrogens, here you have 3 hydrogens. All here 3 bonds, here 3 bonds, here 3 bonds. 9 bonds, this was one more. And here 3. So many bonds are there. One bond means 2 electrons. So many electrons are there in this molecule. So between those electrons, electron repulsions takes place. Bond and bond will undergo repulsions, which we call that as steric hindrance. So this nucleophile cannot approach from the back side, so it cannot come over like that. So first what happened? This is the step 1. So nucleophile won't approach from from back side. So in step 1 what happened? First, Mr. X, you please go from here, it will say. Then with a sad face, that will go. So you are having methyl here, and here you have one more methyl, and here you have one more methyl like this. So this is step 1. So what carbocation here you have? Tertiary carbocation you have. Okay. Now in step 2 what happened? This tertiary carbocation, for that, who is going to add? Mr. Nucleophile. Okay, here you have a methyl, here you have one more methyl, but that particular nucleophile can approach either from backside. For that particular nucleophile can approach either from front side. Both are possible now. Why both are possible? Because one bond removed. Suddenly this become planar. In previous, this is sp3 hybridized tetrahedral. All the bonds are in non-planar manner. Certainly more repulsions. But now all bonds came in the same plane. Now this is the planar. When the species become a planar, repulsions will be minimized because all are in a uniform manner. So now nucleophile can approach either from front side or either from back side. Suppose this is a front side approach, suppose. Imagine like that. So my work will be easy for you. Now what happened? Suppose now this C approaching from a front side, and here you have a methyl, and here you have a methyl, and this nucleophile is coming from front side, suppose, like this. Now nucleophile approaching from back side. Now see, and here you have a methyl CH3, and here you have one more methyl, and here you have one more methyl. Now nucleophile approached from back side. So this is a mirror images. So what you are having here, racemic mixture. Racemic mixture is forming when the nucleophilic substitution reaction happening by Sn1 mechanism. Understanding everyone? So when Sn1 mechanism happen, when the groups are very big. Got it? So if you understand this chemical properties, it's just matter of 5 minutes or 10 minutes. You can understand very easily. So till here you have to remember, okay, order of leaving group will be more here. Okay, for same iodine leaving group, who is the best leaving group means, even for Sn1 also I minus is greater than, Br minus is greater than, Cl minus is greater than F minus. And if you see the reactivity of halides, tertiary halide is more reactive than secondary halide than primary halide. In previous also I was given order of reactivity in both Sn1 and Sn2. Please go through those. So very important. Thank you, and we will continue from chemical properties. Take care, and still if you have any doubts, please ask me, no problem, I'll explain. Okay, but write down everything. And one more thing, take care about your health. That is very important. That will give you more confidence. Okay, all the best. Thank you.